Hi everyone, welcome to e-learning. So in the previous session, we discussed about CRO and its functional parts. In this session, we are going to discuss about dual tracing CRO and the probes. So we came across the CRO, so where we went across many functional blocks of CRO. So that is what fundamentally necessity for dual tracing CRO. It is basically is nothing but two CROs connected in for dual tracing. So we can see the dual tracing diagram in the next concept. Okay, so this what is the concept of dual tracing is nothing but, so it allows two independent signal, whereas in the CRO where it's going to allow only one independent signal, whereas in dual tracing it allow two independent signal going to trace themselves. Okay, in this session, so we are going to discuss about dual tracing. So you can see the block diagram of dual trace. We are having only one screen where the signals will be flowing in two direction, so there will be, hence the signal will be traced twice, hence the name dual trace. So we have preamplifier and attenuator. Sometimes if the signal is very low in level, it's going to amplify. If it is very high in level, it's going to attenuate. Hence, so system is going to automate the input signal either by amplifying or by attenuating, followed by delay line and vertical and horizontal amplifier, what we already discussed, and along with that we have a triggering circuit also with this, and then we have a deflection plates, horizontal and vertical both, that we already studied across. Okay, we'll go through one by one each. The preamplifier and attenuator are going to, we have two inputs, so channel A and channel B. So what happens, sometimes we are going to give the input and we need to have the look at the output during that time. So if we just have a look at the output, it's not enough, so we need to compare the input with the output during that time. So we need to have two displays, input as well as output. For example, take in your laboratory or even in your integrator or differentiator or somewhere circuit, so you need to compare the output with the input. So hence we need to trace two signals. For that we need dual trace oscilloscope. So inputs will be given at the inputs. We will be having two inputs, hence they will be called as channel A and channel B. Both are inputs only. They will go through delay line, either attenuated or amplified, and they will fit to vertical amplifier and through vertical deflection plates. In the following section, in the below of the block diagram, bottom of the block diagram, we have a switching circuit that will be switching between A, B and external input. It will be, the switching speed will be very high, hence we cannot differentiate whether signal is deflecting or not. So indirectly when you check, actually they will get a spot, but this switching will be very high in speed, so it usually in the megahertz, hence user eye cannot detect the differences in spots. Later it follows through sweep generator. So where in the CRO we are going to use the sawtooth waveform, so in this we are going to use the sweep generator is fed, and through vertical amplifier it will be given to CRT. In the block diagram you can see, so CRT is cathode ray tube. So once the beam electrons emitted from the electron gun are going towards the screen, they will be accelerated, they will be focused using anode, then they will pass through vertical deflection plates, successively horizontal deflection plates, then they are going to finally hit the screen. Once they hit the screen, their kinetic energy will be dispersed as light energy. But the advantage here is we will get the two focus at any point, because we are going to trace two signal at a point, so channel A and channel B. What happens, actually channel A will be traced for certain period, and then channel B will be traced again, channel A but channel B, and then channel A channel B. But this switching between channel A and channel B is very fast in nature, so we cannot detect the signals. Okay, so next concept what we have is probes. What is CRO probe? Probe is nothing but the component that we are using in laboratory to connect from circuit or to connect from to input a signal to CRO. So we need to have a signal shape in the CRO. For that we need to give the input signal through which we need to give through probes. They will be classified as direct probe, high impedance probe, active and current probe. So we'll discuss one by one. So what is direct probe? Usually what we use in our circuit laboratory is nothing but direct probe. They will be having two wires and usually they will be coaxial, one conductor followed by one, so surrounded by the insulator, again circulated by one more conductor, and finally we have the one more insulation. They will be connected directly. So usually one side we will be having a connector terminator, so another side we will be having a crocodile pin. So everything is insulated. So usually it will be used at low frequency and low impedance circuit, like so filters, amplifiers, all these things. When you have a high input and high frequency, we should not use direct probes. So what is next? We have high impedance probe. High impedance means when the input signal is very high in amplitude, so that may affect the circuitry, and during that time we are going to use the high impedance probe. There we will get even 10:1, 50:1, 100:1. Okay, direct probe is nothing but 1:1. So high impedance probe. So as you can see in the diagram, you will be having a filter circuit, RC filter circuit at the input, followed by the cable, and that will be given as output to the CRO. So usually they called as 10x probe, where the signal is attenuated. If the input voltage is 10 volt and the output voltage to the CRO will be only 1 volt, it's going to attenuate by 10 times. In this you can use for very high frequency or very high amplitude. Okay, next we have active probe. So what happens when we have filter circuits where the frequency will be keep on changing? So I cannot go with a high impedance probe. High impedance probe works only when the input voltage is very high. So during that time, for very high frequency circuits, we should have active probe. They will be having a FET source follower, that means field effect transistor source follower, then followed by a BJT emitter follower. So whatever the input that you have given will be passed through gate drain source circuit of FET as well as BJT, emitter base collector configuration, through emitter follower function, then it will be fed to cable. What happens here? Any fast rising signals, any highly active signals, any high frequency signals, very peak, very slopey signal will be passed as usual. So normal in the direct cable or high impedance cable, the sweep or fast rising will be attenuated. In active probe, so it will be passed as usual from the input to the CRO. So during high frequency and very fast range of fast rise time or very sweep frequencies, we should use the active probes. The last one we have current probe. So current probe, usually when we want to isolate the circuit, we need not to connect the isolate, just when we want isolation from the input circuit, then this probe will be used. Usually this will be very high in conductivity due to higher diameter conductor, hence it will be having capacity of 1 to 2, 3 ampere up to current to the CRO, so that it will be attenuated at the CRO level. Usually it will be used in all effect generation, where the EMF will be very huge in nature. During that time the current flow will be high. For that we need a contactless flowing of current, hence for that we need to have current probe. That's all for the session. So thank you everyone.